Hello, grade 9. In this video, we will talk about direct variation and inverse variation. Direct variation and inverse variation. Unit 2, Lesson 3 in Algebra. In the first, we talk about the direct variation. Direct variation. Okay. Now, if you have a car moves at uniform velocity v, okay, 15 meter per second. If the covered distance d in meter in a time t per second, okay, to give what? To give the relation d equals vt. The relation equals d equals vt. Now you have a table. This table shows what? Show when t, the time, equals 1 second, d becomes 15 meters, okay? And when t equals 2, the distance becomes 30 meters. And when t equals 3 seconds, okay, the distance becomes 45 meters. Also, when t equals 4 seconds, the distance becomes 60 meters. Now, we can represent this relation graphically, okay? So this figure represents the relation between d and t, okay? The horizontal line represents the time in seconds, and the vertical line represents the distance in meters. And we know something, okay? This relation is represented by a straight line passing through the origin point, okay? Now, here d equals vt, and v, the velocity, equals 15 meters per second, and it is constant. So v equals d over t, okay, equals 15. So d over t equals a constant expression, which is 15, okay? So you can take velocity v and put it 15, okay? So d equals 15 t. And it is said that what? It is said varies directly as x. Here, d varies directly as t. d varies directly as t. And it is written by this sample, okay? d varies directly as t. Now, if you have y and x, and y varies directly as x, so it is written y varies directly as x, okay? And here m equals what? Equals not equal to 0. M is a constant number, so the relation equals m equals mx, y equals mx. We find the relation y equals mx, where m is a constant number and not equal to 0, okay? Now, I said before in the previous figure, the relation represented by a straight line passing through the origin point. Because what? Because it is a linear relation. So y equals mx is a linear relation between two variables in the first degree, okay? So y equals mx is a linear relation between two variables, x and y. And it is represented by straight line passing through the origin point, okay? Now, if the variable x takes two values, x1 and x2, and the variable y takes the two variables, y1, y2, we find that y1 over y2 equals x1 over x2, okay? And if y equals mx, then y varies directly as x. And here, if y varies directly as x, then y equals mx, okay? For example, here, if y varies as x, y varies as x. Then y equals what? 14. Y equals 14 when x equals 42. Then find the first one, the relation between x and y. The second, find the value of y where x equals 60. Now, I said what? I said y varies as x. So, y equals mx, okay? Y equals mx, where m is a constant number and not equal to 0. Now, when x equals 42, y equals 14. By substituting the values of x and y in this relation, we get what? We get 14 equals 42 times m. So m equals 14 over 42 equals third. So the relation between y and x equals third x, okay? The second required here, find the value of y when x equals 60. Now you have the relation between y and x, okay? So when you substitute by the value x equals 16 in this relation, we get the value of y. So when x equals 60, y equals what? Equals 20, because y equals third times 60 equals 20. So when x equals 60, y equals 20. The second type here, inverse variation. Now, if the area of the rectangle M, the area of the rectangle is M, okay? And one of those dimensions x and the other dimension y. We know the rectangle have two dimensions, length and width, okay? One of them is called x and the other is called y. And the area of the rectangle equals length times width. So the area here, m, equals x, y, because the two dimensions here, x and y. So the area, m, equals x, y. And if the area of the rectangle is a constant number, equals 30 centimeters squared, okay? 30 centimeters squared. Now, by substituting the values of area here in this relation, we get xy equals 30, okay? Xy equals 30. If you separate between the two variables, okay, we get y equals 30 over x, 30 over x. And I said before what the 30 or the value of the area is a constant number here. So y equals m over x. And here m is a constant number. Where not equal to 0, okay? M constant number and not equal to 0. Okay. Here we can say what? We can say y varies inversely as x. Y varies inversely as x. And it is written y varies inversely x by the sample, okay? Like here. Another way, if you separate between x and y and put y in one side, we get, input x in one side, we get x equals 30 over y, okay? So, x equals m over y. Then, x varies inversely as y, and also denoted by this sample, okay? For example, and also where m constant number and not equal to 0. For example, here, if the variable x takes two values, x1 and x2, and also the variable y takes two values, y1 and y2. Here, and we get when y varies inversely as x, y1 over y2 equals x2 over x1, okay? xy1 over y2 equals x2 over x1 when y varies inversely as x. The previous relation is not a linear relation between two variables, and it is not represented by a straight line passing through the origin point. Because what? Because here the relation xy equals m of the second degree, okay, not the first degree. So xy is a relation on the second degree, so it is not represent what linear relation between two variables, and it is not represented by a straight line passing through the origin point. Example number 2 here, if y varies inversely as x and y equals 3 when x equals 2. Now I said what? Y varies inversely as x, so y equals m over x. Here I need to find the relation between x and y and the value of y when x equals 1.5. Okay, I said before y equals m over x, okay, where m is a constant number not equal to 0. By substituting the values of y and 2 in this relation, we get the value of m. So y equals 3, x equals 2. 3 equals m over 2. So m equals what? Equals 6. So the relation equals y equals 6 over x. Now, when x equals 1.5, y equals what? Y equals 6 over 1.5 equals 4. When x equals 1.5, y equals 4. Now we have some exercise. The first one, complete. If y varies directly as x, okay, then x1 over x2 equals y1 over y2, okay. If x varies inversely as y, then x1 over x2 equals y2 over y1. Now, if y equals 2x, then y varies directly or inversely as x, varies directly as x, okay. Here we know something, each variable here in one side, okay, x in one side, y in one side, so y varies directly as x. But here you have in number D 2xy equals 5, 2xy equals 5, then x varies inversely as y, okay, because the two variables here in one side, okay, xy, multiply with them in one side. Here, if y varies inversely 1 over x, and, okay, y varies inversely x, and y equals 3, as x equals 20, then y equals what when x equals 12. So here y varies inversely x, therefore y equals m over x. We need to find the value of m in the first. So by substituting the values of x and y in this relation, we get 3 equals what? Equals m over 20, okay? So m equals 3 times 20 equals 60. So the relation equals y equals 60 over x, okay? Now, y equals what when x equals 12. Okay, here you can substitute by the value of x here in this relation by 12. So y equals 60 over 12 equals 5. Equals 5. Okay. Here a second exercise. If x power 2, y power 2 minus 6xy plus 9 equals 0. This expression, x power 2, y power 2 minus 6xy plus 9 equals 0. Then prove that y varies inversely as x. Okay. Here, this expression, you need to find relation between x and y. Okay. Now, here you can factorize this expression into two brackets like this, okay? x2, y2 equal x, y, and x, y. Here, 9, okay? 9 equals what? Equals 3 and 3. 3 times 3, okay? Now, positive and here negative, so you can put positive as the same sign of the middle term, okay? Equal 0, okay? The same bracket, you can take 1, so x, y minus 3 equals 0, okay? So x, y equals 3, okay? Here you have the two variables on one side. So y equals 3 over x. Therefore, okay, since x equals 3 over x, therefore y varies inversely x. Okay? Another exercise here. If y equals 1 plus p, where p varies inversely as x power 2 and y equals 17 as x equals 0.5. Find the relation between x and y. Then find the value of y when x equals p, okay? Here you have the relation y equals 1 plus p, but p here varies inversely as x power 2, okay? P varies inversely x power 2. Therefore what? Therefore p equals m over x power 2. You can substitute by the value of p in this relation. I said before here y equals 1 plus p. You can put the value of p here. So y equals 1 plus m over x power 2. By substituting the value of x and y in this relation here, y equals 17 as x equals 0.5, okay? So y equals 17 equals 1 plus here m over 0.5 power 2, okay? Equals quarter. Here you can move 1 to another side with the opposite sign. We get 16 equals 4m, okay? So m equals what? M equals 4. So the relation equals y equals 1 plus 4 over x power 2, okay? Find the relation between x and y. Y equals 1 plus 4 over x power 2. Now find the value of y when x equals 2 only. So substitute by the value of 2 in this relation. We get y equals 1 plus, okay, 4 over here 2 power 2 equals 4 also. You can simplify it, equals 1 plus 1 equals 2. So y equals 2 when what? When x equals also 2. Okay? I wish you have a good idea about this lesson. Thank you for listening. Goodbye.